Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for a little bit more practice on rearranging equations with the Batty Boffin. I've got three equations here and what I'm going to ask you to do is change the subject of the formula. Okay, just a quick explanation of what that means, a little recap here. The first equation over here is actually a formula we use for cooking meat. What that means is that the time it takes to cook the meat is, that's in minutes, is 25 times the weight in kilograms plus 25. So if you've got something that weighs 4 kilograms, then you do 25 times 4 and then add on another 25 minutes and that's the cooking time. So that would be 125 minutes, that one. Okay, to see how that goes, 25 times 4 is 100, plus 25, 125 minutes. Now that's all well and good if you know the weight of the meat you're trying to cook. Put the meat in there, put the weight of the meat, it gives you the time. But what if you've got the cooking time? Okay, so you know you've got to cook it in a certain time and you want to know what is the weight of the meat that you could cook in that time. We need to rearrange this equation so that instead of saying T equals and then blah 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 with a W in it, we need W equals blah 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 with a T in it. Okay, and that's called rearranging the equation to make W the subject. Okay, so off you go. Right, we're going to do this by the Cadbury's cream maker method because it's my favourite and most of my students like it very much. W, imagine that as being the prize in the middle of a pass the parcel, or the centre of the Cadbury's cream egg, and it's got a times by 25 and it's got an add 25 layer around it. We're just going to put some circles around to say that this one is the closest in. We know that because times and multiplies come before adds and subtracts in the order of operations. And then, woo, that's the kind of weird looking wobbly bit there. The add 25 comes later. So when we unwrap those, we take them from the outer layer working in. For Cadbury's cream eggs, you have to eat the chocolatey bit and then the white bit before you can get to the yellow bit in the middle. Okay, if in your country you don't have Cadbury's cream eggs, complain vociferously until you do. So first thing we're going to do is get rid of that add 25 by doing a subtract 25 on both sides, which gives us T minus 25 equals 25W. And then we're going to get rid of that times 25 by doing a divide by 25 on both sides. And that gives a T minus 25 whole thing divided by 25 equals W. Just to check that that is correct, we're going to put in the values that we did on the tryout one. I'm going to put in a value of T equals 125. So we're just going to substitute in, this is an extra just to check that my equation works. So 125 for my T, take away 25, divide it by 25. A lot of 25s in this, aren't there? And the answer should come out to be the weight of meat that you can cook in that time. So in 125 minutes, take away 25, that's 100. 100 divided by 25 gives us a value of 4 kilograms. So you could cook a 4 kilogram piece of meat there. And yeah, that's right. We knew that. That was the one we used for testing at the beginning. So there we have changed the subject of the formula. Here's a really famous one. You must have seen this before, okay? This tells you what's going on inside nuclear reactors and indeed inside stars, which are nuclear reactors. It's all rather groovy, isn't it? E equals mc squared. Could you please rearrange that to make c, which is the speed of light, incidentally, a very large number, make the c the subject of that formula. Off you go. This is a pretty simple one. There's only a couple of layers and nothing complex in it. We've got the squared bit first and then the multi. I'm going to have to go around there. That looks like a copyright symbol, doesn't it? Okay, so the first thing we're going to do is move the m by doing a divide by m on both sides, which gives us E over m equals c squared. And then we're going to get rid of that squared by doing a square root on both sides. So a big square root, E over m equals c. The square root of E over m equals c. Okay. Final one over here, we've got one that looks a little more complicated. This is the formula for the volume of a cone. Okay, pi r squared, you'll recognise that as the area of the circle, times it by the height, and that would give you the volume of a cylinder, divide it by 3 and you get the volume of the cone that would fit inside the cylinder. And that's always true. The volume of a cone is always 1/3 of the cylinder that it would fit in, which is rather clever really, isn't it? Right, I'd like you to please rearrange that, and I'm feeling nice, so let's make H the subject of the formula, please. Have a go with that. Now there's not actually as many layers in this as you might think, okay? So H, we've got it multiplied by some stuff. Now you could do it in 3 stages. You've got it multiplied by the r squared, and you can treat r squared as just a number. If r is 4, then r squared is 16, so r squared is a number. And we've got it times by pi, so you could do times by the r squared and times by the pi and then divided by the 3. You could do it in 3 layers. Or you could bear in mind the fact that r is just a number, r squared is just a number, and pi times r squared is just a number. Okay, so we could, I'm actually going to do this in one big chunk over here, times by pi r squared. Okay, pi r squared, all as one chunk. And then I'm going to do the divide separately. You could, if you wanted to, be really fancy and do them all as one go, but chances of getting something wrong there is larger, so I'm going to do it in 2 chunks here. Okay, so first thing I'm going to do is get rid of that 3, and this is a good technique for anything you're doing, is if you've got something over something, multiply by whatever's on the bottom of the fraction. It generally simplifies pretty much anything, so if in doubt, multiply by whatever's on the bottom of the fraction. So I'm going to do a quick multiply by 3 there, which gives me 3v equals pi r squared h. Okay, and now I'm going to divide by that whole thing, pi r squared, divide by pi r squared. If you're not happy doing pi r squared altogether, please feel free to divide by pi and then divide by r squared. Okay, just make sure you write it right. So on the left hand side we're going to get 3v over pi r squared, and on the right hand side we've got h, and there's our formula. If you did it in 2 stages, just be very careful that you didn't do something like going 3v divided by pi and then divided by r squared. Please don't ever write anything like that. That is just horrible. We don't do multiple stacked fractions because who knows what that is. Just horrible. No, just no. Blech. If you're dividing by pi, if you then divide by r squared, that just goes on the bottom of the fraction. We don't add another stack to it on there. Okay, so those are those 3. I hope you're happy with those. A good bit of rearranging. Come back on the next one and we're going to move up a notch. See you then.